of the day is Ueda, who is going to tell us about homological symmetry for the Milnor fibers of invertible polynomials.
Thank you very much for introduction. And first, I would like to thank the organizers for the opportunity to give a talk here. So I will discuss my joint work with Jan Kiri. Well, so we start with an n by n matrix with whose entries are natural numbers, and we assume that a polynomial defined by this formula, this is an assumption that so this defines a regular map on Cn, and we assume that the origin is an isolated critical point. So and also we assume that the determinant is non-zero. This is where the invertible comes from. So, and then we can form another polynomial which is called the Belgian-Hubers transpose. And we introduce an abelian group of rank 1 defined by the following formula. So it has n plus 1 generators with relations of the following form. So C is equal to so where I runs from 1 to n. So this relation means that this ring may be B. Defined at the quotient of the polynomial ring by this transpose is L-check graded. Actually, I think it's more convenient to start from x0, and my degree xi is when I is 1 up to n, and then if it's 0, then it's c minus 1. Sorry, I should put something here. x0, so the product of, so n plus 1 variables. So here, so this f check lives in here. But this sits naturally inside here. And the x0 dependence is only this product. And we consider well, this kind of grading, and this relation ensures that, well, this, well, polynomial is, well, homogeneous of degree C, and these are just symbols which, well, represents the degree of xi. And so these relations are the minimal relation which allows one to, well, grade. Well, so this is a grading, well, natural grading on the polynomial ring which makes f check homogeneous. And then we can state the main conjecture, well, and which is that the wrapped chi category, well, derived and split, taking idempotent complete derived, well, wrapped chi category of the Milnor fiber. Because this is weighted homogeneous, the Milnor fiber is just the fiber over 1, and this is equivalent to the singularity category of the, well, L check graded B check modules. So this is the main conjecture, and this is something I want to discuss today. And so, and also, well, we expect that this is the wrapped chi category, and this is a, well, compact chi category, and this should be the, well, full subcategory consisting of C with, well, the dimension of the total home, well, is, well, finite for any in the wrapped chi category. And well, maybe, well, we can just be vague about. So well, you can think of this as, well, either a subcategory here or here, but anyway, you know, well, so for any, so sorry, so in here or here, but so all right. Well, I can write in this way, and but this is in terms of subcategory as here, but we can, well, instead of so subcategory of something, and this can be either this or this if this is equivalent. So this is, well, completely categorical description. So this one can be either left-hand side or right-hand side of this equivalence. So, and let me, well, give a few examples of, well, invertible polynomials. So, well,
did you say that the critical points are isolated?
Yes.
Some condition, right?
Yes. So this is an assumption. So.
Do you mean the condition is determined from 0?
Yeah. So sorry. Assume this one and this one.
So what is the condition on matrix?
Well, it is known that, by Kreutzer and Skark, it is known that, well, this kind of, well, polynomial can be written as a, well, Sebastiani-Thom sum of, well, three basic, well, kind of polynomials, which are called, well, Fermat, loop, and chain. But basically, well, so it's, well, What? So there is some kind of classification of, well, matrices satisfying this condition. But anyway, well,
You mean the answer is not wrong?
there's a very explicit description of, well, the matrices satisfying this. Well, and it's like, so, well, yeah, maybe we can discuss it later. But there are infinitely many examples, and the simplest one are Fermat type polynomials, and so in dimension one, the only possibility is that, well, monomial, so it's not very interesting. Well, it's already non-trivial, but anyway, let me discuss the case where n equals 2, and then, well, the simplest one is this A1 singularity, and then, well, in this case, well, so the Milnor fiber is, well, the C star, and in this case, it's elliptic curve minus 1 point, and in this case, elliptic curve minus 2 points, and well, in this case, well, one has elliptic curve minus 3 points, and there are other cases like this one where we have genus 3 curve minus 4 points, and so on, and so the this case is log Calabi-Yau, and these three cases are Calabi-Yau minus, well, ample divisor, and this case is, well, general type minus ample divisor, and so these cases are log general type. And so on. There are infinitely many of them, and also there are something which is not Fermat. But anyway, well, and this is a situation in dimension 1, and in dimension 2, one has, well, so in this case, well, the Milnor fiber is just cotangent, well, bundle of the sphere. And well, there are, well, AD cases, and maybe the most interesting one is, well, E8 singularity. These are Kleinian singularities, and these are, well, log Fano cases. And which doesn't exist in dimension 1, and then we have, well, log Calabi-Yau case, well, which are, well, so this case is then, well, 6 point blow up minus elliptic curve, and and these are del Petro surfaces of degree 2 and 1 minus smooth elliptic curve. Well, and also we have, well, more general thing like and in this case one has, well, Cardic K3 minus genus 3 curve, and so on. We also have general type minus ample divisor, and these are smooth divisors. here the complements are smooth? Well, basically because the singularity is isolated, and one of the questions that we want to ask is, what is the quotient of the rough sky category modulo the sky category? And well, I don't know how much is known for this kind of question, but well, this conjecture suggests that there's a trichotomy in the description of this, and so this is a rough sky category. Well, this is a very general question for that you can ask for maybe dubious domains, or maybe even more general situation like wherever you can define rough sky category. And the situation that we are working with is the Stein case, so it's the one of the nicest situation. But anyway,
What is this quotient?
yeah. So well, you can define abstractly, but you want to know more explicit description of this, and so for log, so maybe for log Fano case, maybe what one gets is something like generalized cluster category, or something like that. And in the log Calabiao case, the mirror will be another log Calabiao. That's what one expects. And then, it's like, and if the mirror is affine, then it's a, this is a, category of coherent sheaves, and this will be mirror to the category of compactly supported coherent sheaves. So coherent sheaves modulo compactly supported coherent sheaves, and I don't know how much is known about that kind of category. But, and in the case of, Calabiao minus ample divisor, smooth ample divisor, then our speculation is that this would give the Fukaya category of the divisor. So maybe I will write it. Well, we expect this kind of thing, and this conjecture implies that this in some cases. And
so I assume when you say Fukaya category, you have in mind Z-graded category?
So here it's only Z mod 2 graded.
What was the last question?
So here is Z graded. So these guys are Z graded.
Right. What I'm trying to say is that the answer, even in the Calabiao case,
Yes.
will depend on whether you take the Z-graded or the non-Z-graded category.
Yeah. So here we consider Z graded category, and we consider Z mod 2 graded category, and here too. Yeah. So the generalized cluster category is kind of periodic. So for instance, if it's as far as I know, the generalized cluster category is.
What you said about the last line.
So
What is this?
The claim is that the Verdier quotient is somehow related to the Fukaya category of the divisor.
yes. So
Are you saying there is a natural factor, or are you saying that you can have?
the natural factor, more or less, and there is something called restriction factor, which is described in, for instance, Daniel Ru's paper, with a word speculation in it. Well, and so the restriction functor should induce well equivalence with well this category. That's well our expectation. Well, so let me discuss examples. So we want to think about this. So and then well, so we define y check to be so we have a well natural action of this group in here and well this is where the well quadratic mirror lives and then well by Orloff theorem, well, this is equivalent to the derived category of coherent sheaves on Y check. And on the other hand, well, if you think of well this equation, well, inside well P3, so well, you can see that well, this is a well obtained from well, this guy is a cuspidal rational surface. So it's a rational surface with one cusp singularity and obtained well from well this is P2 and you have well the coordinate triangle and then you pick well 12 points which are intersection of well this curve with this well coordinate lines and then this is blow up. So if you well blow up these 12 points, then you will have -3 curves here. So you have a triangle of -3 curve, and so you can contract it to a cusp singularity. So this is a minimal resolution of cusp singularity, and so this surface is obtained like that. And this one is so this is a stack quotient. So the quotient of this guy here, and then so the singularity category of this Y check. So it is well the category of matrix factorizations of X with this group action, and this one is mirror to well the category of a genus 3 curve. Well, so it's a variation of well Zeidel's genus 2 well homological mirror symmetry and its generalization by Efimov. And well this is slightly different, but it's kind of analogous situation. And so Yes, yes, equivalent matrix factorization with respect to this group. Hmm? Mm-hmm. Yeah, so yeah, that's right. So this is defined over C or Q. Well, this is a monotone case or anti-monotone case. So this is, well, always of general type. So it's an smooth ample divisor in a Calabi-Yau. So it's a, well, anti-Fano case. So you can define everything over C. So you can consider balanced, well, Fukai category. Well, that's how, well, for instance, Zeidel's or genus 2 curve story works. So yeah, you can work over the Novikov ring if you like, but you
The statement is okay. It's okay the statement you made without any problem.
So sorry, the question is.
D is compact.
Yeah, D is compact. Yeah, and this guy, everything is over C. Well, and one remark is that, well, this is also related to, well, Atsushi-Takahashi's conjecture and, well, Elsa-Keating's theorem. Is that, well, the Fukai category, well, maybe I should write, well, yeah, the Fukai, well, the derived category of coherent sheaves on well, something defined by this equation inside, well, so this is an orbifold projective line with, well, 3 orbifold points of order 4, and this guy is equivalent to the, well, Fukai-Zeidel category of, well, so this is a, well, Fukai category of leftist vibrations. So the Fukai-Zeidel category. So that's a mirror symmetry for, well, weighted projective line, and so this is kind of, well, cover, or, well, it's something like cover of this story. But anyway, so we, yeah, and we want to, well, discuss how to prove this kind of, well, statements. So there are at least 3 approaches. And, well, one is a, well, cover a pair of pants. Well, after Zeidel and Sheridan. Well, so you can intersect the Milnor fiber with, well, the torus, and then, well, this is a, well, cover of a pair of pants. And because well then this works well basically for the compact sky category and not for the rough sky category for the moment. But so at least for this I see. Well, so invertible polynomial is well exactly well in the class of well polynomials where this holds. But well in examples you like for instance for Brice confirmed linearity this is well fairly obvious I think. Well they take this for instance for this guy. Well,
I agree sometimes you can check if you're saying that it's a true fact.
Yeah, so the definition of invertible polynomial is well kind of designed in such a way that this holds. So and then this is mirrored to well this kind of equation inside some let me think. Well, so well some quotient of well c n plus 1 modulo some group. Well, and then well this k is well such that the group of characters is the L that well we introduced in the beginning. Well, and then well they are adding boundary divisors. Is mirrored to well adding well deformations by adding monomials. Well, in general, well, this can be very complicated, but in this particular case, well, the argument of well Sheridan, which well originally goes back to Zaido, can be well generalized in a more or less straightforward way, and one can prove that well. So this line of argument will give well. So then, well, how shall I write it? Well, then we. So we can prove that well that. So for instance, in this case, well, that well. This one can be shown to be equivalent to perf of y check, and here this is well. This is a subcategory generated by the particular Lagrangian. Well, Sheridan's Lagrangian. So one has an immersed Lagrangian inside the pair of pants, and when you put it back to here, then well you will well have well collection of Lagrangian spheres, and then well so if you take the well full subcategory generated by that and a split closure of that, then well it will be well equivalent to the well in the Calabi cases, well it will be equivalent to perfect complexes over well the mirror. And in the non-Calabi case, well this side can be described only in terms of matrix factorizations.
Assuming you made a statement here, apologies. Is the point, are you saying that you can calculate all those extra disks and it matches with the solution you wrote for?
Well, that's something like that, but it's well. The argument here is a bit more sophisticated, but it's well along the lines of it's very similar to well Sheridan's proof of homological mirror symmetry for well Fano hypersurfaces in PN. So
Sheridan's proof has an important additional fact, which is that object generates.
Yeah, so we don't have generation at the moment. We don't have generation statement, and that's why we have to say well this 0 indicates that.
I understand, but you can say whichever extra disks show up when you add these boundary equalizers, you can actually count them. That's the content of the statement you're making.
Well. And it's basically that kind of thing. And the second well line of argument is more well kind of more streamlined, I would say, more conceptual. And that's so for if well the polynomial is a Sebastiani-Thom sum, so of two well invertible or maybe in general well so polynomial with isolated critical point. Then well one should have push out diagram. Like this. So it should come from the sheaf theoretic well property of the chi category, but so something wrong. This actually is a well chi-sidal category, but so and then so this W is a wrapped chi category. So all W are so well. So if inside well you have a symplectic manifold inside W, then that's wrapped chi category. And well. And if you have well fibration inside it, then it should be the chi-sidal category. And so the conjecture is that, well, one should have one push-out diagram like this.
Why do you say should have? Why is it just true?
Well, so this is like, so you consider, well, say, well, so consider F plane, and how should I write it?
I understand why it should be true, but why isn't it just true?
Well, why this should be true? Yeah.
I understand why it's not just a theorem.
Yeah. Well, why it's not a theorem? Well, maybe it's a theorem. Maybe yeah. It should be a corollary of, well, your oh yeah. Well, I don't know, yeah, the exact status of the, well, your work, and yeah, maybe it's a theorem by, yeah. And similar, and the corresponding, well, push-out diagram on the mirror side. Well, and on the mirror side, it's like, well, really the gluing of, well, varieties. Well, you know, well, but you know, instead of, well, explaining what happens on the mirror side, well, you know, and let me just remark that, well, for more for Breeze confirmed singularities, so well, the conjecture to n equals 1, which is straightforward. Well, it's fairly, well, easy to check the conjecture for n equals 1. One can compute the both, well, sides explicitly. Well, maybe I can say a few more, and maybe I can say one more remark. Well, and in Oru's speculation paper, he conjectured that, well, for hypersurface inside, and he conjectures that, well, in the diagram, and there's a way to construct the mirror. Well, I don't describe how to, well, define the mirror, but it's, well, I believe it goes back to Katsarkov maybe, but well, then there's a way to construct mirror for in this situation, and the Oru's conjecture is the following diagram. And this should be equivalent to coherent sheaves on Z. And the restriction factor. And this should be, well, and this one should be, so this is a natural projection, and this is, well, something called restriction. And so one should have this, well, diagram. So that, and this is certainly related to, well, this kind of story. And so it's a Calabi-Yau minor sample situation, but this Calabi-Yau is non-compact, so it's slightly different in that sense. But and there's, well, and the third way to prove, to approach this conjecture, at least in the case of, Brice confirmed similarity, there is an approach using parameterhedral, skeleton. So this originally is, for the mirror of, say, mirror of pair pants, or, actually that, it goes back to, my joint work with, Masahiro Futaki, but we didn't say anything about, Lagrangian skeleton, but, and then there's a more recent work by Gamish-Nadler, and they have, pair of pants have a, Lagrangian skeleton. And consisting of parameterhedra. This is a generalization of hexagon to higher dimensions. It's a close cousin of associated hedron, but I don't describe what it is. But so the intersection with the torus also has a parameterhedral skeleton, and then adding a divisor, adding boundary divisors. Should correspond to removing cells, and at least for the Brice confirmed case, by imitating their argument, we can construct a parameterhedral skeleton which is obtained by removing, well, cells from parameterhedral skeleton of this guy. Well, maybe I can explain the case where, well, maybe this case, well, I don't know. And in this case, well, how should I write it? Well, maybe I write it in yellow. So the parameterhedral skeleton looks like this. So, well, sorry. So sorry for the bad drawings, but this is a division of, well, torus into how many? One, maybe three. Yeah, three hexagon. Really, three. Well, anyway, it's a division of torus into hexagons. Well, these are hexagons, and well, this is a skeleton for the intersection with the torus, and then the skeleton for well, the Milnor fiber is just the part of it where one removes some of them. So it's actually union of, well, two hexagons like this. Well, it's just that, but well, it's some subcomplex of this guy. So taking this guy and this guy.
Can you explain why adding divisors is supposed to remove parts of the skeleton?
Well, so yeah, I have to admit that this is kind of vague, and well, so well. At least, so we have observed, but so for Brice-confirmed singularities, somehow it works. Well, but so removing, well, and it's, yeah, this parameterhedral, well, skeleton, well, in this dimension actually is a ribbon graph, and then, well, if you remove, well, something from the ribbon, so ribbon graph describes, well, Riemann surface with boundaries, and somehow, well, removing something from the ribbon graph will result in change of topology of the Riemann surface, and somehow, so this guy is, well, elliptic curve minus, I think 6 points maybe. All right. Oh.
Basically, you're saying if you have to remove a puncture, it's like joining
Yeah. Well, what? I think it's 6 points. And then this is elliptic curve minus 1 point, but well, and finally, let me say a few words about generalizations. And well, let J be, well, the Jacobian of a genus 2 curve C, and then, well, the conjecture is that, well, the rough sky category of the, well, Jacobian minus the theta divisor, which is isomorphic to C, it should be, well, equivalent to the, well, derived category of coherent sheaves on, how should I write it, maybe Z. And where Z is, well, something, well, obtained from a toric variety by identifying, well, boundaries, -1 curves. So this is a moment polytope for P2 belongs at 3 points. So it's a del Petro surface of degree 6. And then, well, we identify these, well, -1 curves. Then you get some singular surface, and that's our Z. And that the conjecture is that it describes this. And then also, well, this fits nicely with this conjecture. So this should follow from, well, from this line. Well, so if you take an universal cover of this, then you should have this kind of, well, equivalence, but for infinite, well, toric variety of infinite type. So, well, this is very analogous to that conjecture. This is, well, Z is obtained by, well, identifying the opposite edge. But instead, you can take, well, infinitely many, well, so you can consider tessellation of planes by, well, hexagons, and then consider the corresponding toric variety of infinite type. So it's an, well, infinitely many, well, del Petro surfaces, well, glued together along P1s. And then you're in this kind of situation. Well, and on this side, it's really the universal cover. So the Jacobian has an, well, you take the universal cover of the Jacobian and take the pullback of the, well, theta divisor. And, well, and this should, well, and this should generalize further to well, type 3 degenerations of K3 surfaces, etc. But I stop here. Thank you.
Thank you. Questions?
Oh, well. So in this case, it's not a point. So here instead of, well, h or then the point. You mean invertible polynomial, or so this story is different from the invertible polynomial story. It's and the yeah. So this is generalization, but it's in a different direction. So this is, well, so something that I wanted to say is, well, so this is a Calabi-Yau minus sample divisor situation. And in some case, one should have this kind of derived equivalence. So the removing a divisor should be related to degeneration on the mirror side. And so, I think in general, it's difficult to tell which degeneration corresponds to which divisor. So there are cases where one can, guess, what the, degeneration is. But in general, so for any, maybe not necessarily smooth divisor inside. So you can take arbitrarily ample divisor inside any Calabi-Yau manifold, and then the complement will be Stein manifold. And then, one should ask if you have a nice description of the, Fukai category in terms of, algebra geometric object. And this gives one such example. So, yes, yes, it's smoothest to an abelian variety. So that's a central fiber of the manifold degeneration. Yeah, abelian surfaces. Yeah.
Do you know the relationship between this conjecture you're saying and Catherine Canizio's thesis? Because she worked out near symmetry for genus 2 curve via embedding it inside its Jacobian and then working out near symmetry for the Jacobian.
Oh, really? I didn't know that.
That picture appears. In fact, I think you must have been doing the other side of what she did. She's the Neo student. She's finishing this year.
So it's not published yet? Or?
I don't know.
I didn't know that, yeah.
More questions? How much does the Thomas Sebastiani help you? I mean, does it reduce you to some finite problems, or?
Yeah, it reduces to, some basic cases. And there are 3 cases, called, chain type, loop type, and the Brice confirm type. So yeah, and there are infinitely many cases that one has to check. But still, it's a reduction.
More questions?